How are you, everybody who is watching this video? My name is Olenjolain Single. Primarily, I would like to thank you to welcome me in your iPhone, to welcome me in your smartphone, to welcome me in your smart TV, to welcome me in your iPad or your iPod. And I would like to thank you also to welcome me in your PC or in your personal computer or in your desktop computer. And I would like to thank you also to welcome you in any electronic device that you are delivering this signal. I'm from Tanzania. I'm a Tanzanian and I'm from Tanzania. I want just to welcome you into our online institution that's called the Online Undergraduate Polytechnic Institute of Tanzania in Olenjolain. So this is an online platform where we train students on higher engineering mathematics and higher scientific mathematics for undergraduate students. So I'd like to remind you the vision that we have into this the vision that we have in this online institution. This is the vision that we have. We would like to incubate and prepare a group of students who are ready to take the classroom instructions combined with the spiritual instructions, whether they used to get themselves through the Word of God or whether they will get through these programs, because we have also some other 2 YouTube channels that we are training students about the spiritual knowledge, and especially that the Word of God or the Word of the truth. To combine, so they have to combine these 2 knowledge. It means that the classroom science or classroom engineering, engineering concepts or engineering knowledge with the spiritual concept or with the spiritual knowledge in order to solve real life problems. So our rejoice is not to see our students are graduating in colleges, and our rejoice is not to see our students are passing exams. Our rejoice is seeing our students are solving real life problems. That's the intention, and that's the main goals. And also we are born to solve a problem or problems in this planet Earth. So myself, this is one of the problems that I'm solving, meaning that it happens. Many students or many undergraduate students, they used to fail to understand and even to master some courses or modules in mathematics due to the various reasons. So I'm solving it. How am I going to solve? I'll be taking those concepts and I'll be make like a student's self-learning materials. I'll break them, the complex concepts, I'll break them and make them simpler and simpler and simpler, so a student at any level can take those stuff, and especially that who has been prepared to acquire the concepts of that level. So that's the main goals, and that's our main goals and our main objective, to see students that they are taking the classroom instruction that will give them and combining with the spiritual knowledge, and then they solve the real life problems. So we have our YouTube channel is also called the Online Undergraduate Polyinstitute of Tanzania. This undergrad, it means the abbreviations of this word. So from U to D, it means of undergrad. Poly is abbreviations of this word from these 4 letters, the first 4 letters. Institute, these are the first 6 letters of this word institute of Tanzania. Square bracket, Olenjolaim. So even here there's Olenjolaim. So that's our official YouTube channels. We'll be uploading almost more than 200 videos in that YouTube channel. So you have to make sure that you subscribe by using your official email, and hence that once you subscribe, so then you get a notification and even access of all of these resources, which actually that in case we ask you to pay for, you should have to pay a lot of money in order to get this program. But by God's grace, that this is my Thanksgiving, I'm offering this content right now free of charge. So I don't charge you anything else. If you are buying the bundle, it's just for you to have the internet. It's not just you are paying for me. Or in case that you buy an electronics device, you are buying a device for you. I won't get even 1% of what that you are going to use on buying the phones or buying the bundle. So I would like to offer my Thanksgiving or offerings to God through this program, who has given me a gift of teaching. So that a piece of information that I want to let you know. Again, that we don't want to waste much of your time. So we have one of the departments is called the High Engineering and Scientific Mathematics. And some of colleges or universities or institutions which are under the NATE, we call this level NT level 7A. The modules or course is called calculus, and this is the reference instructions is DIT. The year of study is first semester of the first year. Right, to do the quick review. The topic or the chapter that we are going to learn today is called Theory of Limit for Limit. And this is lecture 2, applications of informal definitions of a limit or of limit of the function. Okay. Then in case that you feel from your heart that you want to offer God your free willing thanksgiving, you hear the voice of the Lord in you. Don't hesitate yourself. You can send your thanksgiving through this telephone number 0759 74 53 31. And the registered name is Olenjolai Tayai. So, well, your thanksgiving will have been received and will be used effectively to perform this work according to the will of God. Well, so in case you have questions, don't hesitate yourself to the comment sections to ask many questions as well as you can. And also you can use the comment section to submit the homeworks, because you have to make sure that you do the homeworks of the certain lecture before you take this next lecture. So that's the way that we would like to insist you to go through. So the quick review of lecture 01, first of all, I define the concepts of limit, literally and even geometrically. Then later on, I discussed a little bit about, so define the concepts of limit. And later on, hopefully, I think that I have touched about the concepts of the first principle of calculus, if I'm not mistaken, according to my remembrance, what I still remember. And then another thing that we have learned in this lecture 01, where that we had a good foundation on lecture 01. So we talked about first principle. No, not the first principle. Yes, okay, first principle, yeah. Can even have the image of first principle. Well, so again, I told you about geometrical definition of of a limit. And then later on, I talked about informal definitions of a limit. Formal definition of a limit. And then after covering the concepts of informal definition of the limit, informal definition of the limit, then simply I challenged you with some few situations, etc. But the general formula for the limit of the function is a limit as x approaches to a, but not that x is equal to a, of a certain function f of x. This is equal to limit L. But also I say that we have limits of left-hand side, which is say that x approaches to a bar of f of x, and then this should be equal to the limit as x approaches to a positive of f of x. So this is the limit of left-hand side, limit of right-hand side. This also is equal to L. Okay, so that's all about session 1. So in case you want too much details, we spend almost 2 hours on explaining all of this stuff. So make sure to go through. Again, I insist you to watch this lecture 00. The general introductions of what of calculus is very important to watch it several times as well as you can, so that you can build up your mindset. Right? Okay, so now let us come to applications of informal definition of the limit. So remember that mathematical informal definition. Mathematical informal definition of a limit. We say that we have a limit of left-hand side, which is limit as x approaches to a bar of f of x. This is equal to limit as x approaches to a positive or 40 of f of x. And this is equal to what? Limit as x approaches to a of f of x. And this is equal to L. So this is the general definitions of the limits. So this one, we call it the limit of left-hand side, and this is the limit of right-hand side, and this is the general definition of the limit of the function is equal to L. So that's what I told you about the mathematical definition or of informal, the mathematical informal definition of a limit, this one. We say that it's not precise, the precise one is formal definition, but also you can do a lot of things on this one. So basically, there are two applications, okay? So let us go. There are two applications. Make sure that you watch lecture 000, General Introductions of Calculus, lecture 01, General Introductions of the Theory of the Limit. So there are two applications of what? Two applications of limit of the function. Limit of the function. The first one, we say that there are two applications of what? Of informal definition. Not formal. We are still in informal definition. There are two applications of what? Of informal definition of the limit. The first one, to check whether the limit of the function f of x, of the function f of x, function f of x exists or not. So it checks the existence of what? Existence of the limit. So we say that there are two applications of informal definitions of the limit. To check whether, so say that to check whether the limit of the function f of x existing or not. That's the first application. So I have two examples to demonstrate that application. The second one, to say that if the limit of the given function exists, then the informal definition is used to find it. It's used to find it. The formal definition is used to find it. Okay? So it means that another application, second application of informal definition, it's used to find the limit of the function. So let us begin with the first. That begins the first applications. Okay? Existence. So the first application called existence. Of a limit of the function. Of a limit of a function. So how can we comment or conclude that the limits of the function, so the function existing, and the limits of the certain function does not exist? This is the condition. The necessary condition of the limit. The necessary condition of the limit. The necessary condition of the limit. The necessary condition of the limit of the function. The necessary condition of the limit of the function of the function to exist is the limit as x approaches to a bar. This is the limits of left hand side. This should be equal to the limit as x approaches to a positive of f of x, right? And this one, so this the limit of left hand side should be equal to the limit of right hand side, and this will be equal to the limit r. So that's the necessary condition. So if a limit of any function existing, it means the limits of left hand side should be equal to the limits of right hand side, and that equality value will be the limits of the given function. Listen carefully. So that is the necessary condition for the limits of the function to exist. Okay? So, say that if the limit of the function, of the given function, of the function does not exist, then we say that the limit as x approaches to a, this is left hand side, f of x, will not be equal to limit as x approaches to a positive of f of x. So that's the conditions for the non-existence of of the limits of the function. So for this case, you find that the limits of left hand side will not be equal to the limits of right hand side. That's all. So let us see examples. I have two examples. One of example, I will show you how we conclude that the limits of the function exist, and the other function we will conclude that the limits of the function does not exist. Does not exist. So let us see example. This will be example 1. Let me start in different way. Example 1. Say example 1. Given limit as x approaches to negative 3x plus 9 over x squared minus 9. So you have Roman 1. Thus the limit of the function exist just 1, 2. If yes, if the answer is yes, then determine it. That's all. So given limits at x approaches to negative 3x plus 9 over x squared minus 9, and Roman 1, does a limit existing? That's the question mark. And the second Roman, if yes, then determine it. So solution. I will teach you how to solve this problem by following 5 steps. So you have to listen careful, and you should have your scientific calculator beside you, because we are going to use this soon. The first step, we say that simplify the given function. So simplify the given function. So we have limit as x approaches to -3, and hence you have what? You have 3x plus 9 over what? Over x squared minus 9. So in this one, what do we say? That we say, while this is limit as x approaches to -3. So take 3, it is common, so take 3 out, you have x plus 3, and then here you have what? X minus 3 times x plus 3. Okay? So what do you say? So you say that this one, so let me write it clear. So you have limit as x approaches to -3. You have to enjoy the beauty of higher engineering and scientific mathematics. And then there in numerator you have 3x plus 3. In denominator we have x minus 3 times what? X plus 3. So this one and this one will cancel. Right? Then we have limit. We are still simplifying the given function. We didn't deal with limits yet. So the simplified function is 3 over x minus 3. That is the first step. So we cannot simplify further to this, further from that point. So that's the last point. Right? The end of simplification. Then we go for the second step. The second step, we say that represent some neighborhood values of x is equal to -3, okay, on real number, or on number line. What does it mean? Listen, suppose that here I have a number line, and then I want to magnify this -3. So on this side I will have -4. Again on this side I will have -2. I will have -1, then possibly I will have 0 somewhere else there. Listen carefully. So, remember that when I've been teaching about geometrical representation of the limit of the function, then I told you that all of these values are on left hand side of -3. This we call them x is less than -3. And in maths we write that the x approaches to -3, but bar. You have to remember that. Right? So what are the smallest values? So you say that what does this mean? It means as we approach x is equal to -3, we should be expected to get the value of y. So listen, so the values which are, for example, this one is -3.5. So as long as the next one maybe it is -3.25, etc., etc., etc. So that is on left hand side. We are going to use this one. Again, we have the right hand side. So suppose that this is -2.5. So if also some values which are closer to -3 but they are not equal to -3. Okay, for instance that we can have that -2.9. -2.9. -2.99. -2.998. See? So those are the values. So simply, what does it mean? So this is what I mean. Suppose that you have a number line, and this is negative 3, and this is negative 4, and this is negative 2. So we can have, so suppose that we have magnified this part and this part. It's not like that does in real sense, but we want to demonstrate it to you. And then we say that for this case, we say, okay, well, so we have that. Suppose that this one is negative 3.5. Negative 3.5. Negative 3.5. And then we have again the other value. This other value is what? Negative 3.8. No, excuse me. Negative 3, let's say 0.2. Then here we have negative 3.8. So we can choose some values near to negative 3 on left hand side. And then we can choose some values, for instance, that the middle value here is negative 2.5. Then we have some other values close at negative 3. The closest value is negative 2.99, negative 2.98. So those are the furthest values. So what does it mean? So listen carefully. So you can take considerations of left hand side itself. This is negative 3. Suppose that this is negative 2.20. This is negative 3.20. 0.10. The next one is negative 3.08. The next one is negative 3.06. So you're approaching it. So the next one is negative 3.04. The next one is negative 3.02, etc. So we are approaching negative 3 from the left hand side. So that's what you are trying to find the limit of left hand side. So you go for the third step, say steady step. Steady step, so you say that so we say that it's made the corresponding values. It's made the corresponding values of y by using those of what? Those of x. Okay, what does it mean? Listen carefully. Suppose that this is x and this is y, right? So then we have these values. Okay, so this is what, so you say that you like to start far, is negative 3.10. The negative 3.08, the negative 3, so you're approaching what? Negative 3.06, negative 3.04, as I told you, negative 3.02. Then we reach what? This is negative 3. So it means that this side, we say that we are approaching negative 3, and this we define that as x approaches to negative 3 bar, right? And then we have again some other rows. Then we got the right hand side. So right hand side again we say that okay, so you can move from negative 3 towards negative 2. So this one will be negative 2.99, negative 2.98, negative 2.96. So negative 2.94, negative 2.92, right? So it means that if you'll be moving toward this one, it is positive. So you say as the x approaches to negative 3, positive. So this is right hand side, and this is the limit of left hand side. So you want to fill this column of y. So how do we get the column of y? We should take y, which is equal to 3 over x minus 3, and plug it, or it means that in place you have to insert it. You have to insert this equation into the scientific calculator. So let me claim this place. If you're joining me right now, you're welcome. We are in session 2 of calculus, and the reference institutions is the Islam Institute of Technology, so you're warmly welcome, but it can be used in nationalized in any institutions where we have what scientific courses or engineering courses. So you go for the first step. So the first step, we say that insert the function in the scientific calculator. In the scientific calculator. So what the equations that we have, as I said, y is equal to 3 over x minus 3. How do we insert it? So first of all, you have to press alpha, then y. So you have y on the screens, you press alpha equal sign, and then you press 3, then you press this fraction sign, then you open bracket, you press shift alpha x, no, you press just alpha x minus 3, you close bracket. Then you calculate the buttons, that's the bulletins calculate. So let me show you. This is our scientific calculator, right? I can bring it closer and closer like this. Okay? So, what's happened there? So you have this on already. So you press alpha, then we come y. This is y. So then we say that, okay, alpha, then we press equal sign. Right? And then see what you have our equation. It is 3. Then you have what? Fraction sign. Then open bracket. To open bracket, we have what? Alpha x minus what? 3. So you say what? We close the bracket, no? So we close the bracket like this one. So next, you press the buttons of calculating, asking you for what? The value of x. So the first value of x, it is negative 3.10. Then you press equal sign. It is negative 0.49. Negative 0.49. Then you press again calculate. You insert for x is equal to what? Negative 3.08. So 3 of what? Alpha x minus 3. Means you say that calculate when what? When x is negative that ones, answer is negative 0.49. Then again press calculate. The next value there it is what? Negative 3.08. Negative 3.08. Right? You see it? You press equal sign. That says negative 0.493. Negative 0.493. Then we calculate again for what? Press calculate, then you have negative, press negative 3.06. This is negative 4.9. Then calculate negative 3.04. It's negative 4.9. So then we have negative 3.02. This is equal to negative 0.5 if you approximate. Alright? So negative 0.5. So again you say calculate negative 2.9. So the answer is negative 0.5 in 1 decimal place. Then we calculate. The next is negative 2.98. So we say that we have 3 shifted, and in case that you find that the function has disappeared, don't panic. Just reset it. So we have negative 2.98. So this is negative 0.5. This is negative 2.96. This is negative 0.5. Again, we have to inject negative 2.94. This is negative 0.5. So that is negative 2.92. It's negative of 0.5. So those are the estimated values as long as we approach negative 3 from left hand side towards negative 3, but we don't reach negative 3, on from the right hand side where that we have to make sure to click it. Okay, so it means that now the entire expressions will be like this one when inserting the scientific calculator. So we say that so we still have to proceed. And the way that we have to proceed, we say that, okay, so we've got the values, then we have to test them. Right? Okay, so according to this platform, we say that it's a kind of the challenging to deal with this case. So let us go for the fifth step. So the fifth step now, we want to generalize. What can you notice from this y column, so second column? All the values are the same. If you estimate this in 1 decimal place, they are the same. Right? That's very important, and I think these are the same. So the fifth step, we say that let us now commenting in general. Okay? So how are you going to comment in general? We say that first of all, we have two sides. We have from the left side towards the point, or from the right hand side towards the point. So right now we say that we have this guy. Okay? So we say that comment in general. So we say that so comment not in general. So we say that basically on the numerical values, okay, numerical values shown in table, 1 below, 1 above. So we're looking for these numerical values. This. So based on the numerical value showing in the table 1 above, then what? Based on the numerical values shown in the table 1 above, so we say that as we approach to negative 3 from there. Okay, as we approach negative 3 from the left side. From the left side. As we approach negative 3 from the left side, so then, what do you say? So as we approach negative 3, which is this one, from the left hand side, what do you notice? So you notice that all of these values are the same value, right? So the same value. So these values are the same values up to here. So we say that then, so we say that from the left hand side, so then we say then the limit as x approaches to negative 3 bar of 40 of 3x plus 9 over x squared minus 9 is equal to negative 0.5. So the limit, so because that the values are near to x is equal to negative 3 on the left hand side, they give approximately the same value. So then we say that, well, that's good. If we approximate this negative 0.49 is equal to negative 0.5, similarly. Right? Good. So that's the limit of the function. So it's equal to negative 0.5. So we can move on. So you say that if for this case, according to that table, as we approach, so as x approaches to negative 3 bar of 3x plus 9 over x squared minus 9. Right? So this one, we found that it is what? It is negative 0.5. So we are grateful on that, right? So it's equal to negative 0.5. So the limit existing. Why does it exist first of all? Because we say that it exists because as we approach to negative 3 from the left hand side, then those different values near to negative 3 are closely or can be approximately like that, right? Okay. Okay. So that's the fifth step. Then I'll go for the sixth step, means the second part. So he said that based on the numerical values of what? X minus 3. So based on the numerical values of y is equal to 3 over x minus 3, then we say that when we say that the limit, then we say that as we approach, as it approaches as approaches what? As approaches x, or as approaches negative 3 from right hand side of 40 of negative 3. So it means that now we are moving from right hand side, this side, from right hand side toward negative 3. So then we say that then the limit as x approaches to negative 3, like positive, right hand side, right? Of what? Okay, so limits as x approaches negative 3, and then that is we have a positive sign there. Okay, for this function, so this is approximately equal to negative 0.5. Why? As we approach x is equal to negative 3 from right hand side, you find that all of these values are approximately negative 0.30.5. So because they gave us this closely equal value, or closely, we say that because these are evaluations, numerical evaluations give us the same values. Okay, so then we say because they give us the same values in different values of 40 of x, which are greater than negative 3. So how many are they? 1, 2, 3, 4, 5. So they gave us the same value. So that's why that we say the limit of right hand side also exists. So here you say that the limit in L exists. Okay, exist. So similarly, so you say that even there, if you estimate this limit is approximately equal to negative 0.5. Okay, it's equal to negative 0.5, then what you say? So okay, so you say that now the limit of right hand side, right? The limits of f of x is equal to what? Limit of as x approaches to negative 3 of 3x plus 9 x squared minus 9. Okay, so this is what we say that, okay, fine. So yeah, we'll discuss this one soon. So what do we find that? We say, okay, so the limit L exists. Why do we say that it exists? Because there's the same values as long as you approach negative 3. So let me claim this point. Can we play back the video so that you can capture the ones that you haven't noticed? So limiting exists, right? So we say that what we have noticed, the limits of left hand side exist. Remember that this is lefty hand side and this is righty hand side. Left hand side, right hand side. So what do you say? So, wow. So you say that to deal with this scenario, we say that, okay, so because the limits of left hand side, the limit of right hand side existing, then the limit existing, and that's what you call the limit of the function, right? So based on what? On the numerical values. So it means that as we approach negative 3 from the right hand side, then the values of y are getting closer and closer. So that's why that we have such a kind of estimation. So well, so that is one of the points that I wanted to make. So if now the limits of left hand side exist and right hand side exist, then you say that let us check. Let us check let us check. No need even of that. So we say that this is the steady state. No, this was what? Something like the force of 50. So let's say the 6 is stable. So the 6 is stable. To manipulate with this, problem, we say that for the limit of function to exist, then what do you say? For the limits of the function to exist, then for the limits of the function to existing, we say that then the limit of left hand side should be equal to the limits of right hand side. So we say that therefore, we say that the limit as x approaches to negative 3 bar of f of x, which is 3x plus 9, x squared minus what? X squared minus 9. So the limits of left hand side, that's what we have found, that is negative 0.5. Alright? 0.5, negative 0.5. Negative 0.5. Okay, again, another scenario. Limit x approaches to negative 3. This is 3x plus 9 over x squared minus 9. So we say that, okay, limits of left hand side. So limits of right hand side of the same function, this also is negative 0.5. Right? So that the limits of left hand side and limits of right hand side. So because of that, so we say that as x approaches to negative 3 bar of 3x plus 9, then x squared minus 9, this one will be equal to the limit as x approaches to negative 3 positive, then this is 3x plus 9, this is x squared minus 9, and this is equal to what? Negative 0.5. So just to comment, because the questions ask us to, does the limit exist? So Roman 1 said that yes, it exists. Roman 2. Then Roman 2, if yes, then determine it. So Roman 2 said that if yes, limit as x approaches to negative 3. Negative 3, right? Of what? Of 3x plus 9. Of what? X squared minus 9. So this one we found it's negative 0.5. And that's the response. Okay? That's the response. So the limits of the function exist. That's number 1. Number 2, not that's only existing, but also we found it is negative 0.5. Okay, tell me in the comment section if you're enjoying this. The beauty of linear mathematics. Choose me. Okay. So now let me give you example 2, which is the homework, right? Before we meet in the next session, so homework. And this is homework 02. The question is straightforward. Determine whether the limit as x approaches to 3 of what? 3x plus 9 x squared minus 9. That's whether this one exists. Determine whether this one exists. That example 2. And some way to determine whether limits as x approaches to positive 3x plus 9 over x squared minus 9. Determine whether that one exists. And then find limit as x approaches to 3 of what? Of 3x plus 9. Of what? X squared minus 9. So find its limit. Okay, so that is the end of this session 2. I would like to thank God who have prepared me. It's kind of the slightly session, but go through it several times so that you understand. We don't solve all the problems by this method, but it's the fundamental method we want to build the concept of limit in our mind. So I thank God who have been with me, and I thank God who have given you an opportunity to watch these programs and to watch this video. In case you have your free willing thanksgiving for what God has done to you through this program, you may offer through 0759 74 53 31. Make sure that you share these contents with your classmates so you can enjoy it. You can tell them. Right now, the light of 3 subjects that encounter the ordinary students. Okay, so the 3. So that's the situation. So what I want to let you know that make sure that you share this material with your colleagues who are undergraduate in different institutions or colleges and different universities. So I would like to meet you in the next session, which is session 3, session what? So session will be lecture 3, when we keep on solving examples or problems that teach us applications of informal definition. So I'm praying for you, pray for me, so that you may have confidence and even may have knowledge and understanding on executing this program. So may God bless you abundantly and keep you for the rest of your life until we meet in session 3 or 40 of applications of informal definition of the limit. So meet you in the inside of that session of lecture 3. May God bless you.